A proportion is a statement of equality between two ratios. One of our most generic algebraic proportional statements is A is to B as C is to D. So that is a proportion, two ratios that are equal to each other. So a proportional relationship would be if you have two things that are in the same proportion. So for example, 2 is to 3 as 4 is to 6. Now that's a proportion, and it's a proportional relationship. Usually we're talking more about things. For instance, I've heard out on the soccer field the other day, a kid scored and a mom yelled, "Hey, that's $5." So for every one goal, he gets $5. Well, that's all that the kid scored in that game. But what if he were to score 3 goals? Do we know how much money he's going to make? Well, yeah, he's going to make $15. So that's a proportional relationship. The relationship between the number of goals scored and the number of, the amount of money that he makes. Now, on a side note, I did tell that mom, I gave her my unsolicited opinion that maybe she should pay him for assists as well, because that builds teamwork. And she liked the suggestion, and we moved on. And let's move on. Next, we're going to talk about direct variation. So two things are said to vary directly or have direct variation if they form a proportional relationship. So the example I just gave of the number of goals scored and the amount of money earned, that varies directly. So both quantities increase in the same proportion. Another great example of direct variation is the amount of money that someone makes. Let's say that a teenager gets a job paying $8.50 per hour. Well, we already know that this is a proportional relationship or varies directly, because for each hour he's going to earn or she's going to earn $8.50. So again, this is a proportional relationship. It's 850 to 1. And then if we wanted to know how much that person would make in 7 hours, we could write out that proportion. 850 is to 1 as how much is to 7, and we could solve that. But what would the graph look like? So time in hours would be the independent quantity, and the amount of money earned would be the dependent, because it depends on how many hours he works, right? So for every hour, it's going to go up 850. And so for another hour, another 850. And for another hour, another 850. So this starts to look like that. So in a graph, you notice that direct variation, there are two requirements for direct variation: that the points graph a linear graph, and also how much is that kid going to get for working 0 hours? Well, $0, and that's actually one of the requirements. Direct variation will be both linear and pass through 0, 0, or the origin. And it is important that we know that the origin is that ordered pair 0, 0, or where the x-axis crosses the y-axis, however you want to think about it. Now, what does it look like in a table? Well, let me give you an example. The key to seeing if there is a direct variation using a table, let me change my color here, is to check all of the y values over the x values and see if they are equal to each other. Now, first of all, we have to remember that the one on the right is the x, which of course we can see right here, ours is our x. But even in the table, the one on the left is the x, the one on the right is the y. And now I just check it. So is 17 to 2 as, and so I'm going to put a little question mark, 4250 is to 5 as, because they all have to be, if there's 5 or 17, all of them have to be proportional or in the same proportion to be direct variation. 7650 to 9. And I am using the same example. So when I divide the top by the bottom here, I get, 850 every time. And so 850 equals 850. And so because each of the y's over their corresponding x values are in the same proportion to each other, this relationship is direct variation. Again, on the graph, it just has to go through 0, 0 and be linear. The points lie in a straight path, and that is direct variation. And the cool thing is, if this is true, then even though you don't know what the line looks like, you know that the points lie in a straight path and go through 0, 0 because it is direct variation. So in this table, is the relationship between the boys and the girls proportional? Meaning, if we were to graph this, would it be direct variation? This is actually a little true story. My wife's family has 1 boy and 3 girls. In my family, there were 2 boys and 4 girls. And then my wife and I together, we have 3 boys and 5 girls. So you definitely see a pattern. It goes from 1, 2 to 3, so it's adding 1 here, and 3 to 4 to 5, so it's adding 1 there. You also notice that between the boys and the girls, there are 2 more girls in each family than boys. 3 is 2 more than 1, 4 is 2 more than 2, 5 is 2 more than 3. All of these patterns don't mean that it's direct variation or that the proportions vary directly. What we have to do is we have to set up that proportion, that y over x. That's what we have to check. So is 3 to 1 as 4 is to 2, as 5 is to 3? And the answer is no. Of course, 3 over 1 is 3, 4 over 2 is 2, and 3 over 5 is 1 2/3. So this one is not direct variation. If we were to graph it, just a quick graph, if we go over 1 and then go up 1, 2, 3, then we go over 2 and go up 1, 2, 3, 4, go over 3 and up 1, 2, 3, 4, 5. We see that those points lie in a straight path, but does it go through 0, 0? You can see that it doesn't. So it is linear, but it is not direct variation, and the relationship is not proportional. All right, let's say that you're collecting nickels and dimes from just people on the street for you're raising for some kind of like pennies by the inch or something. And the first person gives you 4 nickels and 10 dimes. The second one 6 nickels and 15 dimes, and so forth. 10, 25, 14, and 35. The question is this relationship proportional? And if we were to create a graph, would it vary directly? Do you see how they're really synonyms? Maybe you're thinking, what's the difference? Well, there really isn't. If a relationship is proportional, it will graph a direct variation. It will be linear and go. Remember that direct variation, 2 requirements, linear and go through the origin, or 0, 0. So, but we still just check by doing y over x. So is 10 to 4 as 15 is to 6? And again, we don't know, we're just going to check. As 25 is to 10? Question mark. As 35 is to 14. You could divide it with a calculator, but we could just simplify. I can see that if I divide 10 and 4 by 2, I get 5 halves. Is that equal to, I see that the second one has a common ratio or a common factor of 3, which would be 5 halves. So good. So far, so good. The second one has a common factor of 5. If I divide top and bottom by 5. And finally, 7. So this is a proportional relationship. It does vary directly. The number of nickels and dimes varies directly. And one more question. What if they give me 0, 0 as one of the ordered pairs? Well, is 0 over 0 going to equal any of this? And the answer is no, but you don't worry about that because we know that one of the requirements for it to be a proportional relationship, well, to be direct variation, is that it be linear and that it go through 0, 0. So if it gives you this, then you already know that it goes through 0, 0. The only other thing you have to check for is it linear? So if we were to graph this, you would see that it's a straight line going through 0, 0. If the relationship is proportional, you're supposed to state the constant ratio for the relationship. Well, that constant ratio is what we just found. Now, if you had simply divided it, you would have gotten 2.5 each time, right? Now, 2.5 is equal to 2.5 every time, but that's not a ratio. That's a decimal. So then you would want to convert it back into 5/2 to report the constant ratio.